Hi everyone, in this video we're going to be comparing Python, JavaScript and Golang in terms of their functional programming capabilities. I'm a big fan of functional programming and I've been using it in my own work for many years now. It's actually one of the first videos on this channel that was about functional programming in JavaScript. I recently started learning two new programming languages. I started learning Go last year and I even made a video about learning Golang on this channel, and Python, which I've been using extensively for building AI applications with libraries like LangChain. We are going to look at functional programming concepts like partial application, currying and composition, and specifically how they can be implemented in each of these languages, JavaScript, Go and Python. We're going to evaluate which language offers the most natural support for functional programming in terms of built-in features and cleaner syntax. But before we get started, we're really close to hitting 2000 subscribers. Your support means a lot, and if you haven't already, please hit that subscribe button. Welcome back. I had to record this video on a different day, so that's why the difference between the intro. First, in order to do functional programming, you need functions. So let's start with the first snippet and see how functions are defined in each language. Here we have a function that takes in a number and squares it. So as you can see, the syntax for defining functions in Go and Python are remarkably similar. Sure, Go uses the func keyword while Python uses def. Python relies on indentation and Go uses curly braces, but they both have virtually the same syntax and both include a type system. As you can see, in both Python and Go, we specify the input parameter as well as the output parameter of type int. JavaScript, on the other hand, uses a more concise syntax for defining functions known as arrow functions. Arrow functions are defined using the arrow operator, and they can be written in a single line. You can also notice that JavaScript is dynamically typed. You can of course use TypeScript for static typing, but in the JS snippets you will not find any type annotations. In Go, every file belongs to a package. The package main declaration signifies that this file is part of the main package, which is special. It tells the Go compiler that this file contains the main function, which is the entry point for any executable program. Without it, Go wouldn't know where to start running your code. This is why we need the package main and the main function. Another difference between Go and the other two languages is that you need explicit imports even for simple things like printing to the console. In this case, we're using FMT, which is the format package. This provides a function for input and output, like the print line that we are using here to print the results to the console. Calling the functions is straightforward in all three languages. We can assign the return of a function to a variable and then simply print that to the console. Moving on to snippet number 2, here we see the basic functionalities that these three languages support that make writing functional code even possible. So by treating functions as values, we can pass them around like any other type of data, allowing us to create more generic and flexible functions. This is often referred to as functions as first-class citizens, and I will demonstrate that all three languages treat functions as first-class citizens by creating what is called a higher-order function in all three of them. A higher-order function is a function that can take in another function as a parameter, or return a function as a value, or both. In these snippets, we define a higher-order function called apply operation. This function takes in another function called operation, which is either the add function or the subtract function, and a couple of values. And what it does, it just applies the passed-in operation to the two values and returns the output. As you can see, in all three languages, the syntax is virtually identical. The only difference being that in Go, we had to explicitly type the passed-in function. The passed-in function must be a function that takes in two integers and returns another integer. While in Python, you can see that type hints are optional. So here we don't even type the operation function. So we can pass in any type of function. This will be important later on. Let's move on to closures. So a closure is just a function that remembers its surrounding scope. If a function is defined in another function, the inner function remembers the outer scope even after the outer function has finished executing. This means that it can access and modify variables defined in the outer scope. Consider a scenario where a function needs to retain a value between invocations. For example, a counter that increments each time the function is called. In our example, the createCounter function acts as a factory of counters. So createCounter returns an inner function, and the inner function can access the count variable defined in the outer function. In a sense, it forms a closure by closing over the count variable defined from its enclosing scope. So each counter is a closure that remembers its own count variable. So when we call counter, it increments it each time. Closures are actually a nice way to preserve state between function calls, acting sort of like objects with private variables. Closures can also help encapsulate data, preventing direct access from the outside code. You wouldn't be able to modify this directly. Instead, you would have to call the counter function. Go and JavaScript have similar closure mechanics. The inner function naturally accesses and modifies the outer function's count variable. Python, however, has stricter scoping rules. To modify a variable from the function's outer scope, you need to declare it as non-local. So this tells Python that count is not a local variable and that it refers to the variable from the createCounter scope. Let's now combine all of these concepts in a powerful and often underused technique called partial application. Partial application is a technique for creating a new function from an existing function by fixing some of the arguments of the existing function. For instance, if you have a function that takes in two parameters, foo and bar, using this technique you will apply those parameters one by one. So you will create a new function that has foo already set and returns another function that requires only bar. In this example, we define a function called createGreeting, and this function takes in a greeting and returns another function that asks for a name. So instead of combining this in a single function that takes in two parameters, we have a function that returns another function. This allows us to define different greetings, in a sense reusing existing code for different purposes. We can create two different greetings here, and then we can call each of them with just a name. This is just a small example of what you can do with partial application, but as you can see, by fixing some of the arguments of a function, you can create new functions that are more specialized and easier to use. Partial application works exactly the same in Python and exactly the same in Golang as well. While partial application is effective for functions with few arguments, for example 2 or maybe 3 arguments, each function has to return an inner function that fixes one parameter and it takes in the remaining parameters. So as you can imagine, code like this, where we have nested functions that returns other functions, well, this gets unpleasantly nested. So currying is a related technique that allows us to transform a function with multiple parameters or even a variable number of parameters into a sequence of functions, each accepting a single parameter. The difference between partial application and currying is subtle, and many people confuse one for the other. First, to use currying, we need to implement the curry function in each language as it is not built in. These implementations all use variadic arguments, meaning the number of arguments is not known ahead of time. In Python and JavaScript it's fairly similar. We do this by catching all of the arguments in an array. In JavaScript using the spread operator or the star syntax here in Python. Just take a look at the implementation of the curry function in Python and JavaScript. It's virtually identical. So as you can see, curry takes in a function, and then we check whether we already have all the arguments of this function. And if we don't, we recursively call the function with the next argument. So to give you an example of how this will work, if we have a function add that takes in 3 numbers, if we apply curry to the add function, it will take each number one by one. And since the curry function accepts a variable number of arguments, the add function could have any number of parameters. Again, the implementation in JavaScript and Python is virtually identical. But let's take a look in contrast at the Go implementation. This is the first time it becomes obvious that it's significantly easier to implement functional programming in Python and JavaScript than in Go. Don't get me wrong, it's not impossible. As you can see, I did implement the query function here, but you can see how much more complex it is. And the reason is that Go is a statically typed language, which means that the types of variables have to be known at compile time. So this makes creating a generic query function that works with any type of functions, with any type of parameters, or any arity as it's called. This is way more challenging in contrast to JavaScript and Python, which are dynamically typed, and they allow for greater flexibility in handling types at runtime. To overcome this limitation in Go, we need to use the reflect package, which allows us to inspect and manipulate types at runtime, so we can work with values whose type is not known ahead of time. So in our query function, we use reflect on the passed-in function to determine the number of arguments the function takes in. As you can see, we also need to convert these values to reflect values. This is basically why you end up with syntax such as this. Here we are trying to create the queried function out of add, and then when we pass in the values, you end up with syntax such as this. In contrast to this, which is way cleaner. Moving on to snippet number 6, which is about immutability. Immutability is the inability to change a value after it's created. And this is a cornerstone of functional programming. Immutability also plays an important role in concurrent programming and thread safety. When data is immutable, it cannot be changed after it's created, so this eliminates the possibility of race conditions when multiple threads try to modify the same data at once. Let's see the particularities of each language when it comes to immutability. Let's start with Go and how it promotes immutability using the value types for structs and the standard library practice of always returning new values instead of modifying them in place. For example, if we define a points slice here, and then we simply create a copy of the slice, when we do an append operation or also modify an element, you can see that the original is unaffected. Now contrast this to the JavaScript example, where we use the spread operator to create a copy of the points array, but bear in mind this is a shallow copy. And what does this mean? This means that if we push to the new array, sure, it modifies only the new array. However, if we try to modify a value in the existing array, it modifies it by reference, and you end up modifying the object in both arrays. So as you can see, we set the x to 10, and x is now 10 in both arrays. Let's take a look at how Python handles this. So Python's lists are also mutable. So understanding the difference between shallow and deep copies is important here as well. But as you can tell, Python does offer two ways of copying an array. You can use the copy function, which does a shallow copy that behaves basically the same as JavaScript. But you also have the option to create a deep copy. Sure, in JavaScript there are also libraries that you can use to create deep copies, or you can write your own function to deeply copy an array. But this option that Python gives you is quite nice to have it out of the box. So in terms of immutability, Go by design has emphasis on immutability. Python at least gives you the option to either use copy or deep copy, while JavaScript, well, let's just say it loses in this category. Next, let's look at a few commonly used patterns in functional programming, and that's map, filter, and reduce. So these provide a concise and expressive way to work with collections of data. I will not go over this in depth because I already have a video about JavaScript array methods where I explain this in more depth, so go check out that video. But in essence, these patterns are powerful because they allow you to express complex data manipulations in a declarative way, focusing on what you want to achieve rather than how to achieve it. So Python and JavaScript have map, filter, and reduce as built-in functions. Again, the Python and JavaScript syntaxes are strikingly similar. Go, on the other hand, doesn't have built-in map, filter, and reduce, but of course, it provides the building blocks, basically functions, for loops, and slices to implement these patterns effectively. Now, I won't go over the implementation here, you can find it in the GitHub repo in the description below. But as you can see, it's not that hard to implement any of the three functions. Now let's move on to what I believe is the most important thing in functional programming, and that is function composition, which is the act of building complex operations from multiple simpler functions. For example, real-world data transformations often involve chaining together multiple operations. This is exactly what a variadic compose function does. So again, it's variadic because it can take in any number of functions and compose them, passing the output of a function as input to the next. In that sense, it acts like the pipe operator in your terminal. So this eliminates the need to create intermediate variables or deeply nested function calls and results in more simple and expressive code. So again, just like we did with curry, we also need to implement the compose function in each of the languages because it's not built in. So since compose also takes in a variable number of parameters, we need to use the spread operator in JavaScript to accept any number of functions. We use the star operator here in Python to do the same, while Golang also has the same 3-dot operator as JavaScript does. So again, this is a variadic parameter that accepts a slice of functions, so an array of functions. Each function in the slice must take a value of type t and return a value of the same type t. Now let's look at how we implemented this first in JavaScript. The compose function takes in an array of functions and returns a single function that iterates through all the functions in the array, applying them one by one and gathering the value in an accumulator. This is exactly what the reduce function does. However, in this case we use reduce write instead of reduce, and this is because of how reduce works. Because essentially we want to keep the order. So as functions are passed in, we naturally might expect them to execute one by one from left to right. So first we want to square, then we want to multiply by 2, and then we want to add 1. If we would have used reduce here, internally what would happen is first you would have added 1, then multiply by 2, then square. So the order would have been reversed. Now, in Python, because reduce write doesn't exist, we can still use reduce. However, we just need to reverse the function array. So in essence, to reverse the order. Otherwise, the implementation is exactly the same. Now, in Golang, as you know, we don't have reduce nor reduce write, so we just have to use simple for loops. We just loop over the functions in the array, applying them one by one. And the order here is just naturally kept. And that's a wrap on our functional programming showdown. We've seen how Python, JavaScript, and Go handle core functional concepts, each with its own strengths and weaknesses. So hopefully this gives you a better understanding of how to leverage these paradigms in your own projects. Which of the languages do you think came out on top? Let me know in the comments below. Also, don't forget to subscribe for more deep dives into programming languages and software development trends. We are so close to hitting 2K subscribers, and it would be really awesome if we could push over the finish line. Thanks for watching, and I'll see you in the next one.